Welcome. I'm Professor Richard Tamboro, and I'm demonstrating a traditional hypothesis testing technique for in elementary statistics. We're looking at a hypothesis test for a z distribution, and that requires that the population mean is known. Okay, let's look at what we're going to test. We have a claim. We're going to test the claim that the population average IQ is greater than 100. Okay, so let's look at our data. We have some data. Population average IQ is 100 with a standard deviation of 15. The claim is testing for IQ average of greater than 100, so we need a greater than symbol in the alternative hypothesis. So the unbiased hypothesis, the null hypothesis, always gets an equal sign. Alternative, less than, greater than, or not equal to. In this case, greater than, greater than. You can see that we have an X bar that's greater than, so if everything's looking like it makes sense. Okay, a significance level was given at 0.01, so our alpha is 0.01. A one-tail critical value for 0.01 is 2.326. This is what's called a right-tail hypothesis test. Your inequality always points towards your rejection region. So our rejection region is on the right. Our population mean, that's in the middle, 100. We have a z distribution, so we label the z line. 0 is in the middle on the z-line. And the last thing is to put my alpha up here, 1% in the right tail. Okay, so now I can take the critical value and define the rejection region. So the critical value is 2.326, right tail. All right, the next step is to use the test statistic formula, take the data, and see what we get. If we get a test statistic that's between 0 and the critical value, then we're in the failed or rejection region. If it crosses the line, 2.326 standard deviations, then we're in the rejection region and we will reject the null hypothesis. Okay, here we go. So I'm using the formula. So z equals x bar. So that's the sample mean, 104.5, and you subtract the population mean, 100. Divided by the standard deviation, and that's divided by the number of samples. Okay, number of samples. I guess I didn't write that down. Let's see. We have 150 samples. Okay, so there's a lot of samples. Now, if you have a lot of samples, the effect of having a lot of samples is it pushes the test statistic towards the rejection region. Okay, so typically in statistics, if you don't have a lot of samples and then you gather more samples, if the other data stays similar, you'll see the test statistic move a little bit towards the rejection region. So we have a lot of samples. This is a good study. Okay, so the formula gives us a result. Better be a positive result because we have a right tail, so we're already anticipating a positive result. If you put that in your calculator, you will get 3,674 standard deviations. Positive, that means to the right. Okay, if you're trying this in your calculator, make sure you follow the syntax of especially the parentheses, the divisions, don't leave anything out, and you should get that answer. Okay, so now I'll take the test statistic, put that on the graph. My critical value is at 2.326. The test statistic is out a little bit further. Clearly in the rejection region. So we have a conclusion of reject the null hypothesis. Two types of conclusions: fail to reject the null or reject the null. So in this case, reject HO. So we're rejecting the unbiased hypothesis. That means we have a possibility of an error type 1. There we go. Reject is a possible error type 1. Fail to reject is a possible error type 2. So we rejected the null. That means the alternative is being supported. So what we have is sufficient evidence to support the claim that the average IQ is 100. Done. Thank you.